Okay, let's keep going with exponential equations today. So we're going to review just real quickly rational exponents to make sure we understand how to evaluate them. You're going to need that power sheet, so make sure you have that handy. So this is the one I'm talking about that has the all the powers on it. We're going to need this one religiously today. This is really going to help us as we're solving exponential equations because we're going to be looking for like bases. Okay, so let's go ahead and start with our do now today. So go ahead and hit pause and see if you can evaluate this problem. Okay, let's see how you did. So the first thing I'm going to do is I'm going to write this in radical form on the top and the bottom so I know what I'm dealing with. So my radicand is an 8 and I have a 5 and I'm looking for third powers and I'm going to raise them to a power of 4. So we're looking at third roots. So if I look at third roots, I'm over here on the right-hand side. The third root of 8, if I find the 8 on the right side, I come across, the base number is the 2. So I have a 2, and I need to raise that to the fourth power. And let's find the 125, come across, the base number is 5, and I need to raise that to the fourth power. So let's go down and look at our force. So 2 to the fourth, I'm on the left-hand side. If I come across, I know my top number is a 16. And 5 to the fourth gives me 625. So my answer is 16 over 625. Okay, so as I said today, everything is really about the base. Okay, so when we're talking about the base, we're talking about the coefficient. So if I give you 4 to the third, this is the number I'm talking about, the base, okay, the coefficient. And we are really going to have to rely on this because what we're going to see as we solve exponential equations is that the bases have to be the same. Okay, the bases have to be the same. So I actually have to do some rewriting of equations to make things match. Okay, make things match. So for example, if I see this 5x to the third and I see 5 to the third, I see these like bases. Okay, if those bases are the same, then what I can say is x equals 3. So the powers are going to be equal. Okay, and that is going to work all the time. So same thing here. If I have a base of 4 and a base of 4, I can pull out the powers, set them equal to each other, and solve. All right, so let's put this into action here. And let's walk through a couple problems just to see how this works. All right, so I see that this is a base of 6. Okay, a base of 6. So I'm going to go ahead and look at my powers. And I'm going to go down and I'm going to look at the 6s. Okay, I'm going to look at the 6s. So do I see a 216 on squared? No, I do not. Do I see a 216 on cubes with 6s? Yes, I do. So I am going to have to rewrite this 216 to be a 6 cubed because the bases have to be the same. Okay, so once I have 6 to the x equals 6 to the third, then I know that x equals 3. Again, those pull out and become the same, become an equation. Okay. All right, now let's take a look at this one. So 5 is going to be my base because it's a smaller number, and I know that's a power of 1. So that means the 25 is going to have to become a power of 5. So let's go back to our squares. I see 25 is actually 5 squared. So I'm going to replace the 25 with 5 squared. So I'm substituting in 5 squared. So what I really have, I can put a mark around it, I'm going to write it down here, is this. 2x minus 1 is equal to 1 because the power on the 5 is 1. So I'm really looking at that being my equation. And then to solve it, I know I have to distribute. So 2x minus 2 equals 1. I add my 2. 2x equals 3. Dividing by 2, x is going to equal 3 over 2. Okay? So again, like bases, we're going to pull those powers off and we're going to solve. All right, so let's take some of these and break them down. All right, so 5 and 125. Okay, 5 and 125. So I know, looking at my 5s, it's not a squared. If I come over here, I can see my cubes. 5 cubed is 125. So I'm going to replace the 125 with a 5 cubed. Okay, with a 5 cubed. Now this is what has to happen. I have to see that these are the same. As soon as they are the same, I can pull the powers out. Okay, so I'm going to pull out the x. I'm going to pull out the 3, and I'm done. X equals 3. It's finished. Okay, let's look at the next one. 12 and 144. Well, 12 is probably the base. Sometimes I have to go smaller than that, but we always check the smaller number first, and then we go down from there. So if I look for 12s, so 12, 144, I see 144 right here. That's 12 squared. So I'm going to replace 144 with 12 squared. Okay, are my bases the same? Yes, I see those are the same. So I'm going to pull out the 2x plus 3 and the 2, and I'm going to solve it. Minus 3, 2x is a negative 1, dividing by 2, x equals negative 1/2. X equals negative 1/2. Okay, why don't you see what you can do with the 4096 and the 8? Well, let's see. 8 squared is 64. 8 cubed is 512. So it's not those. Let's keep going. Let's go down here and look at 8s. Well, I don't have any 8s here. It doesn't show me 8. So let's go ahead and get our calculator. And let's figure out what our powers of 8 are. Let's check 8 to the 4th power. That's 4096. That's what I need. So I need to replace the 4096 with 8 to the 4th power. Do my bases match? Yeah, so I get to pull out my equation. X equals 4. Is there anything else I need to do? No, I'm finished. I'm absolutely finished. I don't have to go any further. All right, what about 81 with 3s? Well, I see 3 to the 4th right here when I'm popped back. So I'm going to replace the 81 with 3 to the 4th power. Are my bases the same? Yeah. So I'm going to pull out my equation. I'm going to go ahead and write my equation up here to give myself more space. So 3x plus 1 is equal to 4. And I have to solve that. Minus 1, 3x equals 3. So I know x is going to equal 1. So my answer is x equals 1. Okay, now let's look at this next one because this next one is tricky. So you see how I have a 4 and a 32. Okay, I have a 4 and a 32. Well, if I look at my power as a 4, 4 to the 4th is 256. 4 to the 3rd is 64. And 4 squared is 16. So none of those work. This is one of the situations where I know I have to go down and I have to actually substitute on both sides. So I see over here on the 5th powers that I have a 32 right here. There's 32. Okay, there's 32. So that is a power of 2. So 2 to the 5th. So I'm going to go ahead and write this one as 2 to the 5th power. Well, if this one's a 2, that means the 4 has to become a 2. So what is going to go in that spot? Well, what do I know about 4? 4 is actually 2 squared. Okay, so now, do my powers match? My base numbers? Yes. So now I get to pull out my equation, but this one has a little bit of extra pieces. So I have to pull out the 2, and there is a parenthesis there, and the 5. So 2x minus 3, and I'm going to distribute. So 2x minus 6, and there's a 5. Add my 6. 2x equals 11. Divide by 2. X is 11 over 2. 11 over 2. Okay, let's do a couple more. I want you to kind of take a look at these. Both of these are going to have to go down farther. So we're going to have to do both sides to be able to come up with our numbers, okay? So let's look at our 9s. We'll kind of eliminate as we go. I see that 9 is 729 on the cubes and 9 squared is 81. So that doesn't work. So what number goes into 9? 9 actually has a base of what? Well, if I look over here in my perfect squares, I see 9 actually has a base of 3. Okay, 9 has a base of 3. So let's look at our 3s. So 3 cubed is 27. 3 to the 5th is 243. 3 to the 4th is 81. Well, I still think I need to check my 3's. So let's go ahead and get our calculator, and let's be looking at some powers of 3. So 3, let's check the 6th power. That's 729, so it's still not big enough. Let's change that back to an 8. That's 6561. So let's try 7, because maybe that's where we need to be. And there I am, 2187. So this is actually 3 to the 7th power. Okay, so since that is a power of 3, I absolutely have to get a power of 3. So what is 9? 9 in a base of 3? So 9 in a base of 3 is 3 squared. Okay, are my bases the same? Yes, then they cancel out. Remember, these guys go away, and I'm left with what's left. So I'm going to distribute. 4x plus 6 equals 7 minus my 6. 4x equals 1. And divide by 4. X is going to be 1/4. Okay, see what you can do with the next problem. And you're going to make use of these powers of 2 over here. Okay, powers of 2. We're going to have to move both of them down to a power of 2. So see what you can do with that. Okay, so again, 512, if I look at my 4's, I see that 4 to the 5th is 1024. 4 to the 4th is 256. I don't have anything between 256 and 1024 for a power of 4. So I know that the 4 has to go down. 4 is a perfect square. So 4 has to go down to a 2, okay? And that means the 512 needs to be a power of 2. So if I look at my powers of 2, which are my last column here, I see 512 is 2 to the 9th power. So this is going to be replaced or substitute in 2 to the 9th power. All right, let's substitute. 4 is actually what? 4 is 2 squared. It's right there. So 2 squared. Okay, bases are the same. So again, these are going to go away. I'm left with what the powers are. So 2 times 3x is equal to 9. So 6x equals 9. Divide by 6. X equals 9 over 6. But remember, that has to simplify. So it's actually 3 over 2. And if you're struggling with simplifying, remember, I can take 9 divide 6 and hit my fraction key. It will simplify it on the Desmos calculator. Fractions always have to be simplified, and we leave them as improper fractions. We do not put them as mixed numbers. All right, so see what you can do with those today. We'll work on these some more tomorrow. Again, use that power sheet. Reach out to us if you're struggling. Have a good day.